Okay, I tried to tighten up what I drew last time to make space for what's new here. And what's new here is I'm going to give you a procedure for finding the rules that apply to any particular arrangement of capacitors or resistors. So what I want to give you is a process for redefining the parallel rules and the series rules for capacitors and resistors. So this process here, and then I'll demonstrate it for one particular case. First, you write the equation for whatever quantity is split. Okay, so split quantity. Okay, whether that's voltage. In the case of series, it'll be voltage that's split. In the case of parallel components, it'll be charge or current that's split. Whatever it is, you write an equation for the split quantity, and it's just one of these equations. So this, and this are what I'm talking about. Okay, and then I'll do step 2 in a different color just to sort of highlight things, and because I like using colors. Okay, then you substitute. Oops. Substitute either V equals IR if you're using resistors, just Ohm's law. Sorry, let me do my R a little nicer. Or Q equals CV if you're using capacitors. And what you do there is you take advantage of whatever is the same, and you're taking you're taking the things that get split and turning it into terms of whatever stays the same. So to transform, I suppose the way I put it is transform equation into terms of the same thing, of the same quantity. Okay, and this will be a little bit easier easier to understand once I show you a demo. So either V or I or Q, depending on whether you're in parallel or in series, and then obviously whether it's I or Q depends on whether it's resistors or capacitors. And then step 3, oh, what color haven't I used? Well, it doesn't really need a color because step 3 is just simplify. Okay, so, and what that'll mean actually is you'll cancel whatever is the same. So now that I've thoroughly confused you, what I'm going to do is copy this list of rules, more or less, and then we're going to go to a new page, and I'm going to demo it for one particular possibility. So there we go. Nice. Okay, and so let's do an example here where we're going to do hi, that was my wife getting home. Okay, so let's do an example here where we're going to do, let's do oh, what's a good one? Let's do resistors in parallel. Resistors in parallel. Parallel. Okay. Doop. So yeah, she was getting all over the board, so I had to toss her away. Okay, so we have resistors in parallel. These resistors have resistance R1 and R2. Okay, so in parallel, what quantity gets split? In this case, remember, in parallel, voltage stays the same. That's like height on the mountain. So, and we can even draw these things in if we want to remember. Actually, let me move it down a little bit so I have space to draw my current in. So if we want to remember, we can say that's the voltage change. It's going to be the same. So, and then we have what's split, and that is going to be current. So there's I12 is our current in there. There's I1. There's I2. And I'm drawing in more things than needed just to show you exactly what's going on. Okay. So step 1 is to write the splitting equation. And so that's quite simply I12 equals I1 plus I2. Okay? And then for step 2, we want to substitute in V equals IR, but we want to transform this equation in terms of the same quantity, which is V, right? So V is the quantity that's the same for both. So what I want to do is I want to substitute something in for I to get it in terms of V. So I'm going to take V equals IR and transform that into I equals V over R. Okay? And then what we have is that I12 is, so we can say I12 is V over R12. I1 is V over R1. So that gets us this current. And then I2 is V over R2. I'm making this way more detailed than it needs to be. Once you're good at it, you want to do all this. Okay? So I substitute those things into this red equation, and what I get is V over R12 equals V over R1 plus V over R2. Okay? And then the final step, step 3, is simplify. I did in purple, it's in brown, whatever. Okay, fine, brown. 3, draw it over. Pretend I never did the purple. Okay, and then what you just get is, let me grab a teensy bit more space here. There we go. Okay, what you get, you cancel out the V's, you get 1 over R12 equals 1 over R1. That is an R, trust me. R1 plus 1 over R2. Okay, and this is the way I like to leave it. Some people will try to transform it in terms of like R12 equals 1 over all this. That gets ugly, I think, because you get a fraction over fraction plus fraction, you know, and it's gross. And this shows you, I think, much more cleanly. In fact, let me just write this in big letters so that we can see exactly what it is. This shows you, I think, much more cleanly what the relationship is, and it's sum of reciprocals equals reciprocal of the overall resistance. Whoops, sorry, that should be, and that shouldn't be an equal sign there either. Plus 1 over R2. This shows it more cleanly, and it also makes it more obvious what you would do if you had multiple resistors, I mean more than 2 in parallel. If you had 10, it's obvious from this what you would do, whereas if you transform it into some other form, it's not always clear. And finally, it makes more sense when you're comparing it to capacitors in parallel. And I will show you that. I think I'll do one more video and cover that. But this is the general process for doing any particular case. So what I really recommend, if you're trying to get good at this stuff, is to do it for resistors in parallel, do it for capacitors in parallel. In fact, let me just show you what I would recommend a chart looks like. You do series and you do parallel, and then you do resistors and you do capacitors. And if you want to be really good and understand all this stuff, then you draw in a little diagram for each and show, you know, voltages and stuff and derive it. So for example, for the one we just did, parallel resistors, I draw in a little diagram like that, show R1, that's supposed to be an R1, there we go, and R2, and then have my equation, which is 1 over R12 equals 1 over R1 plus 1 over R2. Okay, so that's what I recommend. Anyway, I may do one more video showing the relationship between these things, may not. So there you go.